Okay, now I can just as easily find the standard deviation for this. All I need to do is take this answer right here that we just found for variance and square root it. So if I square root this, 1.34, then the standard deviation is going to be 1.16. Okay, so this is for variance, and this is for standard deviation. Okay, now if we look at this and say they just went ahead and gave you all of this information. We didn't have to find anything. They just said, here you go. We're going to find the standard deviation. Okay, so how could we find the standard deviation? What would we have to look for? And also, I'm going to ask, what is the mean? Well, notice they give you mu right here, which is your population mean. So your mean would be this 2.1. Okay, now if we were going to find our standard deviation, then what we need to do is we need to add up this column right here. Okay, because if you look back, there's those symbols right there, x minus mu squared times the probability of x. X minus mu squared times the probability of x. So I need to take all of these values right here, add them all up. So that would give me summation of x minus mu squared times probability of x. Once I added all of them up, that'd be 1.05. But I can't stop right there because this is actually the formula for variance and we want standard deviation. So what we need to do to change this from variance to standard deviation is to add a square root. So I need to square root this number, which that is going to give me, I'll write it over here, 1.0247. And that would be your standard deviation for this particular distribution. Okay, and last thing, we're going to identify unusual results with probabilities. So the key thing here is values are unusual if they are less than 5%, or if you take it out a percentage, 0.05. Or another way of saying this, if the probability of some event, we'll call it A, is equal to or less than 0.05, then we say that is unusual. And remember, we said that anything within 2 standard deviations of the mean, all of that was usual, but anything outside 2 standard deviations, that was unusual. Well, the reason why we're saying anything less than 5% is because of this 95 right here. Okay? 95% is within 2 standard deviations. That is coming from the empirical rule. Okay, so then what's left over, if we take 100% minus 95%, well, that gives us the 5%, which is where this is coming from. Okay, but this is what we're going to use to look at probabilities and see if they're unusual or not. Now we're going to look at this probability distribution and we're going to see, well, which values are usual and which one are unusual for this die. So I'm going to look at the probabilities and see if any of them are equal to or less than 0.05, which I have one right here. That's greater than, this is greater than 0.05, so is this, so is this, so is this. This is equal to 0.05. So that means both of these are unusual outcomes, while the rest of it, this, and this, these are all usual outcomes.